Greetings to every one of you. So in this video we are going to discuss another very important concept from data structures, that is isomorphic graphs. Two graphs G and G dash are said to be isomorphic to each other if there is a one-to-one correspondence, that is bijection. It is nothing but a matching function between their vertices and between their edges, such that the incident relationship is preserved. So in this case we have to compare both the graphs if the number of vertices are same, if the number of edges are same, and also we have to verify that if the degree of the vertices are same. Apart from that, one more thing that is we have to check is that the incident relationship between both the graphs are preserved. Then we can call it as a isomorphic graph. Here this is the example. This is graph G and this is the graph G dash. Now let us check the degree of the vertices. If you take the degree of vertices of the vertex A, it is connected with 3 edges, so the degree it is 3. Similarly for B, it is connected with 2 edges, it is 2. Similarly C, it is connected with 3 edges, so its degree is 3. The D is connected with again 3 edges, it is also 3. The E is connected with only 1 edge, so the degree is 1. So the value of the degrees of each vertices of the graph G, if you write it in descending order, they are 3, 3, 3, then 2, then 1. Similarly, if you find out the degree of each vertices of the graph G dash, so V1 we have 3 vertices, false on V1. So that is the degree of V1 is 3. Degree of V2 only we have 2 incidents, so that is 2. Similarly for V3, 3 edges incident on V3, so that is 3. Similarly for V4, again only that is 3 edges, so that is also 3. For V5 it is only 1 edge. So if you write again in the descending order, it is 3, 3, this 3, another 3, then this is 2 and this is 1. So if you compare the degrees of the vertices, they are same, they are equal. Now let us check the matching function of vertices. Compare the vertices between this graph G with G1. If you take that is a vertex, the comparison function of the vertex A, if you compare here, you take A connected with 3 vertices and their degrees are 2, 3, 3. So you have to select a vertex which is having the same degrees. To take V1, so V1 it is connected with 3 vertices, V4, V3 and V2. So their degrees are 3, 3, 2. So A it has 3, 3, 2. The same vertices in the same number of degrees we have for V1. V1 can be matched with A. Similarly for B, if you take B, B is connected with the 2 vertices, so A and C, the degrees are 3, 3. Here we can compare this with V2. So V2 it is connected with V1 and V3, so both the degrees are 3. So matching function for B, it is V2. Similarly for C, C is connected with the B, A and D. Their degrees are 2, 3 and 3. 2, 3 and 3. Okay. So now we take V3. V3 is connected with V4, V1 and V2. The degrees are 3, 3 and 2. So V3 is the correct match for the vertex C. Similarly, for D, D is connected with C, A and E. So their degrees are 3, 3 and 1. Now we can compare this V4. So V4, it is connected with V1, V3, V5. So their degrees are 3, 3, 1. So it is 3, 3, 1. So V4 is a correct match for D. Similarly, the next one is E. F of E. It is connected with only one vertex, that is D. So the degree is 3. So we can compare the V5. So V5, it is connected with V4, the degree is 3. So the correct match for all the vertices, the bijection of vertices in graph G to G dash is given here. Similarly, we have to do the comparison with the edges. As far as edges concerned, we have the edges, that is K1. In K1, it is connected with two vertices, that is E and D. Their degrees are 1 and 3. Take the edge E1. It is connected with two vertices, that is V5 and V4. Their degrees are 3 and 1. So E1 may be the right match with the K1. Similarly, the next edge K2. K2 is connected with A and D. Their degrees are 3, 3. So now here take E2. It is connected with V4 and V1. The degrees are 3 and 3. So that is E2 is the right match. Similarly, F of K3. K3, it is connected with the C and D. So their degrees are 3, 3. So consider here E3. It is connecting V4 and V3. The degrees are 3 and 3. So it is E3. Similarly, for K4, for edge K4, it is connecting the two vertices A and C. The degrees are 3 and 3. E4 is connecting V1 and V3. The degrees are 3 and 3. So it is E4. Similarly, this K5 connecting the vertices A and B, the degrees are 3 and 2. So now take 5 connecting the vertices V1, V2, 3 and 2. 3 and 2. So it is E5. Similarly, for edge K6, K6 is connecting the vertices B and C. Their degrees are 2 and 3. So similarly, consider this E6. E6 connecting two edges, that is V2 and V3. The degrees are 3 and 2. So that is E6. I compare the degrees of both the graphs, both are equal. And similarly, we have compared the vertices of both the graphs. Again, both are same. Similarly, also we have compared the edges of both the graphs. Again, all are same. As well as the incident relationship is preserved in both the cases. Hence, it is an isomorphic graph. So, in this video, we have discussed what is isomorphic graph. I explain with an example. Keep watching. Thank you.